I'm Tim Dettmers. I'm an incoming assistant professor at Carnegie Mellon University. I'm also at the Allen Institute for AI, and I'm a member of CMU Catalyst. And this is a short research introduction. My main focus of my research is to make AI accessible. I want to bring AI to the people so everybody can tinker around with AI, work with AI, and then make it part of their own work. And the main challenge if you want to do this is often you're resource constrained. So AI models have become really successful, but also the resources requirements grew dramatically over time. And so what I do in my research is to make AI more efficient so people can access large models on simple devices like laptops or consumer GPUs. Let me give you a little story what that can look like. So I talked to a cancer researcher, and she was working on the problem where she has a cancer-related data set. Now she wants to fine-tune a protein model so that this protein model can find new cancer-related drugs. She couldn't use AlphaFold, which is a powerful model by Google DeepMind, because it wasn't open source. She couldn't download the weights and fine-tune this model. She could use the open source model ESM1, which is not as powerful, but she's freely accessible. And so she got really excited when ESM2 was released, a new powerful protein model. And so she downloaded the code, she downloaded the weights, and then she wanted to fine-tune it on her cancer-related data, but she quickly realized she couldn't do it. It was just too big. It required too many resources. This is exactly where my research steps in. I help people like, for example, this cancer research. And one method that I developed that was very useful for her and many others is QLoRa. And so usually we use large language models and other AI models in 16-bit precision, so 16-bit per computation. And so what I developed is a fine-tuning technique that only requires 4-bit of precision. And together with other techniques, the memory requirements could be reduced by 17 times. And so what that means is instead of 3 big servers to fine-tune a large model, you only need a single consumer GPU. And that made fine-tuning much more accessible. Another sort of direction, which also showcase how I work on these problems, is a more general. And there what I looked at is, can we take a general model, a foundation model, a large language model that runs in 16-bit and run it in 8-bit and 4-bit? And what are the problems there? And so what I found is if you use the previously Beth method, you see this kind of pattern. And what I have here is on the x-axis, the number of parameters in the large language model, and more usually improves the performance. On the y-axis here, we have the performance across several tasks. What you see for an 8-bit model, that performance improves, but then it sharply drops. And this is very untypical of large language models. And so I analyzed this in depth and developed a solution with which we can compress a model to 8-bit, but it still maintains the scaling behavior. So models get better when they have more parameters. The key insight was that as we scale these neural networks, certain features emerge in this neural network. And you need to understand these features and isolate them in order to compress the model successfully and make it accessible. And so these structures, they only make up 0.1% of the overall neural network. So if you can find them, isolate them, and treat them separately, you have 99.9% in 8-bit and just a little bit in a higher bit precision. That makes this kind of technique very general and very accessible. It also highlights sort of how I work on these problems more generally, and often I go through 4 different steps. The first step is really understanding the information processing in these models. And that means not only for one particular model, but more generally, what are general patterns that we can use to develop general algorithms. And so then I develop these general algorithms that improve efficiency, but that's not where I stop. For me, it's important that my algorithms are broadly accessible. And for that, I need to redesign these algorithms so that they can run, for example, on a laptop or on a consumer GPU. And the 4th step is very important for me, and that is creating open source software so that everything becomes readily accessible. For that, I created the Bits and Bytes library that implements all my research algorithms. It's one of the most popular machine learning libraries out there, growing at 4.1 million installations per month, and it's also widely used across industry. And yeah, this was a short overview of the research and kind of research I do and how I work on problems. If you want to work with me, please get in touch.